Hello everybody, your root beer here, and we're going to continue on looking at the 2001 grade 7 Gauss paper. We're up to question number 20 now. So Anne, Beth, and Chris have 10 candies to divide amongst themselves. Anne gets at least 3 candies, while Beth and Chris each get at least 2. If Chris gets at most 3, the number of candies that Beth could get is 2, 2 or 3, 3 or 4, 2, 3 or 5. I don't understand why she wouldn't be able to get 4, or 2, 3, 4 or 5. Okay. So the question's asking us to divide up candies, and first we take a look at the minimum number. So no matter what, any way we divide the candies, we need to have 3 for Anne and 2 for each Beth and Chris. So ignoring Beth's candies, Chris at least has 2, Anne at least gets 3, so 5 of the candies are spoken for. Whereas Beth must at least get 2, and maybe she can get 3, maybe she can get 4, maybe she can get 5, but she could never get 6. Because that would mean, along with Chris's 2 and Anne's 3, that we have 11 candies. Okay. So at most, Beth can have 5. She has to at least have 2. So what I'm going to do is I'm going to make a chart of the candies that Beth has, the candies that we give Anne, and the candies that we give Chris. To show that Beth can get 3 candies, all we have to do is find a way to give Beth 3 and Anne and Chris enough to satisfy their constraints so that our total is 10. That's all. We don't need to have... don't need to make sure that Beth could always get 3 no matter what Chris and Anne have. No. We just need to find one way that Beth can have 2 candies, or one way that Beth can have 3 candies, and then we'll know that those are possible. All we're asked for is possibilities. Okay, so Beth could have 2, she could have 3, she could have 4, or she could have 5. Now at least Anne is going to have, she's got to have at least 3, Chris has to have at least 2, and at most 3. So we'll just hide these conditions up here. And it turns out that this Chris can have at most 3 doesn't really matter. Because it doesn't matter, like Anne doesn't have a limit on how many candies she can have. So we can say that Chris always has 2 and just keep giving Anne the extra candies. So if Beth has 2 and Chris has 2, then Anne will have to have 6. Does that work out? Well, Beth has at least 2 candies. Anne has at least 3. And Chris has at least 2, and at most 3. Okay, this at most 3 again. Doesn't matter, let's just assume Chris always has 2. We can fill out the rest of the chart. If Beth's going to have 3 candies, we could give Anne 5 and Chris 2, and everything's still hunky-dory. Or Beth 4 and Anne 4, and Chris still gets 2, and that works out. It adds up to 10 candies. So we've spread out all our 10 candies equally. And finally, Anne gets 3 candies, Chris gets 2, and Beth gets 5. So Beth could have 2, 3, or 5 candies. Each of these possibilities is perfectly valid, works for all our constraints. So our final answer is just going to be E, 2, 3, 4, or 5. Right? We just needed one way of giving Beth 3 candies and Anne, Chris making sure that their constraints worked out just to show that Beth could have 3 candies. So everything worked out, and that's question 20, which is the last question in part B. So we'll take a look at part C in the very next video, and I'll see you guys then.